So basically, whenever we have a function call to a memory copy, so string copy or mem copy, we want to consider how many bytes of the first variable are being copied into the second. Because if we can overflow past the limit of the second variable, we can start putting extra bytes onto the stack. And so what we see here is I've defined a breakpoint at return Bravo just after the string copy function. And so in the debugger, WinDebug, I've defined ASCII characters for the variable Sierra. And you see these letters here, A, B, C, D, etc. And so what I've done was I've used my Python script pstring to print every permutation of the first 4 characters of the English alphabet. And so this is useful because each permutation is going to be unique. So we can use the index of the permutations to look for values that appear in the registers and on the stack. So what we see here is the permutations here in memory at the stack pointer. So let's take a look here at the registers. So the stack pointer was at 6C38 8F8D0. So we can see that here. And so then the permutations start down here at 6C38 8F900. And so actually what happens when I step through return to Bravo, I go here and PT to go to the next instruction. And so what we see here is when I print the register values, RBX is now, the values in RBX are actually the permutation values. So what we can do is we look for the index values. So at first I looked for DABC, and I found that the lower end bytes did not correspond to the values in RBX. So what I had to do is, because the x86-64 architecture is in small endian order, so the last byte first, I looked for the reverse, so B, C, A, D, and then C. So I found index value 16. So what that tells us is that starting at the value of Sierra on the stack, if we go to the byte offset 16, we can actually insert an address. So to get that address, what we want to do is look for the top of the stack when the function returns and use the address of some sort of gadget. So if we have a jump instruction to RBX, then we jump to the value in RBX. So what we want to do is replace the permutation values with an address that starts our shellcode. And then when we do that, we can start executing the shellcode in memory.